Just a few brief comments about paper one. It was relatively easy paper, very, very similar to June 2022, which is a little bit strange because I know they said they were going to make the exams easier, more accessible this year, yet every single pure exam, core 1 further, core 2 further, and now pure paper 1, has been very, very similar to the June 2022. So I would strongly advise doing the June 2022 paper 2, and you'll see I'll make a few comments as I go along. I'm not going to follow this list in detail. I'll put it up in the description so you guys can download it or go to the link on my website afterwards. But just a brief walkthrough of paper 1. Question 1, easy transformation question. F of x plus a type, inverse type, which is slightly out of the ordinary but could come up in a GCSE paper, just swap the x's and y's, and then a modulus transformation question, which was again pretty straightforward. Question 2, nice for a circle question. Sometimes they can come up quite difficult with hidden discriminant or symmetry questions. Sometimes the algebra is a little bit nasty, or especially to know what equation to build, but this was very standard. Find the radius, find the center, and then state whether a point lies inside or outside the circle, so nothing too difficult. Question 3 was an arithmetic sequence question. Again, a nice one with unknowns in it, so you have to use the fact of what you know about arithmetic sequence, having a common difference, and then using that to find your unknown, and then it was asking you to find the sum of a certain number of terms. So very, very standard. Question 4, factor theorem. That was again a standard one. Given a root, you need to factorize the cubic, and then part B was what I call a hidden discriminant question. So the ones, just want to see where I've put it now. Yeah, the ones where it's a certain number of solutions or touches a certain number of times, and this one was very pretty obvious. It just said prove that something was the only root, so you prove that the quadratic, the discriminant's less than 0, hence no solution. So nothing too difficult there. Question 5 was an integral question, but knowing that you can write a limit as an integral, no area like it sometimes comes up with, literally just turning it straight into an integral and then doing the integration, and it was a nice kind of show that question so you knew if you were right or wrong. 6 was, it was a modelling question, and you normally get straight line graphs or quadratics for modelling style questions, like the easy ones, or exponentials, but it looks slightly unfamiliar because you had a power that was a number which you normally don't have. When you plug in the numbers, it just became a linear equation. This one the same, but threw a few people off just because of the fact that you had the number as the power. But again, nothing too bad. Was that question 6? I think I said, yeah. Question 7 was a quartic, which probably was the hardest one so far. Not too difficult, but a lot of teachers don't spend time on looking at derivative graphs, so it tends to be a weakness with some students. But it wasn't too bad. You just had to find the values where it was increasing, which means the function's trending upwards, and then you had to find an equation of the curve given the roots, which again isn't too bad because you just you put it into factorized form. You start with it in factorized form, plug in the roots, i.e. the opposite signs, and then there's always a hidden a value that you don't know, so you have to use the extra point, plug that in, and that will give you a. But very often you get it for quadratics and it's a bit more familiar, right? You just got the 2 roots, or you use, if you've got a vertex, you use the vertex form and plug the vertex in. So it's slightly different, but you just had 4 roots instead of 2. It's still a similar method, so it shouldn't have been too bad. And then there was what I call a solving graphically question, where you want the range of values, and that's where you just look how many times the horizontal line goes through the curve. So again, not too bad. Question 8 was a proof question, maybe slightly harder than most. It was an algebraic one. You had to spot an error, which was pretty straightforward, just they'd expanded a bracket wrong. But the next part was multiples, so it was to do with a multiple of 5. Now, when you check numbers in general, they can be even or odd, so you can write it as 2k, 2k plus 1. Multiples of 3 can be 3k, 3k plus 1, 3k plus 2. But multiples of 5, you have the extra options. You have 5k, 5k plus 1, 5k plus 2, 5k plus 3, 5k plus 4. 5k plus 5 isn't another option because it's just a multiple of 5, but any number can be written as those options. So you just had to test all those options. I think 3 were already given for you. Question 9 was an exponential, I believe. You just had to differentiate it and solve, and then obviously when you rearrange you got to learn, and then iteration, again nothing too bad, and I've got that here somewhere, yeah, under numerical methods. 10 was a vectors question, a very nice vectors question, like finding an easy vector, and then one of your normal like geometry styles of either proving that something's trapezium, rectangle, or something to do with a triangle, like isosceles, right angle, triangle, all the standard things that you get. Now, vectors will probably come up, I'll mention this in a bit, but it'll probably come up again if they're following the theme of the 2022 paper. But it'll be more like a techniques one, where it's like parallel to, comparing coefficients, something like that. Yeah, I'll mention that in a bit. Question 11 was a exponential question, and exponential modelling question. Very ordinary, just had to differentiate to find a rate. So it wasn't difficult, just remember rate of change means derivative, so that shouldn't have been too bad. Question 12 was a graphing question. Well, it had a graph on it, but it was an algebraic question, sorry. So you just had to like solve simultaneous equations, basically as hard as it got, and it ended up being a cubic. A little bit of algebra involved, but just be aware that with the intersections of graph, you either solve them graphically, which was an earlier question, or you solve using algebra. And the graphical ones are normally like number of solutions, right? What line could you draw such that it has this many solutions, or what slope does a line need to have such that it has this many solutions? And we know solutions is always like how many times two graphs cross, so yeah, nothing too bad there. Question 13 was an integral. That was quite an interesting one because it could have been done by parts or substitution. Half my lessons actually did parts and half my lessons did substitution, but really doesn't matter what you choose to do for that. 14 was a nice trig one, because I always say like some students find trig a bit tricky, and if you see my worksheets I do like a massive process elimination of how to know when to use what formula, because that's what the problem with trig really is. It's not that difficult if you know when to use what. But this was an obvious one, like the addition formula, when you got a plus b, it had a plus in it, so you knew what to use. So that was pretty straightforward. And then 15 was an optimization. Doesn't really come up that much, but again came up in 2020, and it was modelling one. You had to find a perimeter of a sector with a rectangle. Just be careful not to like take the bit where the rectangle merges with the sector, because obviously that's not the perimeter around the outside of the shape. But max and min, very standard, and verifying. And question 16 was an area question with a substitution. Not about like integral as they go, because as you know, trig can sometimes come up with these and they're not the nicest in the world. But paper 2 could have a parametric one where you've got the two trig equations, and then you have to form an integral from that using the parametric formula y dx dt dt. So yeah, it was a nice standard result for that. But sometimes with trig, I always say watch out, because your main goal is to get one of the 6 identities, but the 6 standard results I call them. So if you know what it differentiates to, you can integrate it straight away. And trig is all about just using the identities to put it into a form that becomes one of those 6 results. And it might be an easy reverse chain rule one that you can spot it, but when you've got like integral of sine squared, integral of cos squared that everyone struggles with, you've got to remember to use the double angle to put it into the right form that is then one of the 6 results, one of the 6 main trig functions, and then integrate. So yeah, pretty standard paper, but very similar to the topics that came up for Pure 1 in 2022. So I'd say definitely like make sure you go through that paper 2, really important. And what I've just done on this document is I've literally taken all the topics that didn't come up, and some that did come up, but they come up twice, and I've mentioned that, and I've given you whether it's like certain, likely, unlikely, less likely. Binomial expansion didn't come up, so it's guaranteed to come up in this paper, and more likely a year 2 style. And I just made a few comments like watch out for approximations, when the expansion's valid, over underestimates, because that's the trickier part of the question, because the rest is just technique, pretty straightforward. Differentiation did come up with product rule in the numerical methods question, but it didn't come up with quotient rule from a quick glance. So could come up again with stationary points. Implicit doesn't come up all like every paper and all that much. And if you look at a question bank on my website where I've kind of organized every single topic in a search, so you can just type in a topic name and it brings up all the questions in seconds of every single paper that came up for that topic. If you look through that, implicit doesn't come up all that much, but two types to watch out for is when you need to find stationary points or tangent vertical, tangent parallel. You just got to be careful because when you set equal to 0, you don't get x as a number or y as a number straight away. You get x in terms of y, so you have to solve it simultaneously. And then the x in terms of y types, where you get like dx dy, but you want dy dx, so you flip it, but it's still in terms of y, so you need it in terms of x. So yeah, could be that. Differentiation, parametric, really nasty one came off in 2022. Pretty likely, I'd say, to come up in this paper. I put very likely to come up in this paper. If they don't do that, they'll do integration parametric, I reckon. But definitely parametrics will appear in some shape or form in this paper, I reckon. Tangents and normals, again, could come up with parametric. Unlikely to come up just on their own. That's already come up. Related rates very rarely comes up as an entire question. I'm going to make a table of all the statistics of like every single topic and when it's come up over the 2018 to 2024, the new spec. So I'll have that up soon, and you can see for yourself. But yeah, I think it's come up like 3 times or twice even. Differentiation from first principles. Oh, one thing to note for that, it might come up with differential equations because that's how it normally does come up. If it does, that you use the related rates knowledge to form your equation and then differential equations to solve it. And I'm like 100% sure that differential equations will come up in this paper. Differentiation first principles, easy one, just like polynomial question could come up, very standard, x to the n. The worst they could do with that is like a fraction or 1 over a root, so a fraction with a root in the denominator if they're going to be mean. Trig, standard, but for some reason like my lessons always get stuck on it the first time they see it, and even if they don't practice it, they kind of forget that you need to use the addition formula and take out the terms that aren't with h, because we're letting the limit as h goes to 0, so that's what we care about. Functions, very likely. Domain and range has been coming up a bit more. Watch out for the composite ones and the inverse ones. Possibly domain and range parametric, but doubt it. It used to come up more in the old spec, doesn't come up so much now. Modulus function, very likely. 2022 was really, really easy, so if they do put one on, it might be a little bit harder, you know, the ones where y equals ax plus 3 and then you have to find the values of a such that there's a certain number of solutions. So you think of like what the slope needs to be to cross it a certain number of times. Obviously with these you can always use hidden discriminant, but it's limited. Hidden discriminant only works if you're like with a quadratic and you've gotten rid of the modulus. So I would say if it is a modulus function, your first thought should really be like, how many times do I want it to touch, and then what does the slope have to be, rather than going straight to the discriminant. Graphs, exponential was the one that came up for 2022, so they could ask you to graph that. Very unlikely a polynomial because one's already come up, the quartic. So I would just learn well your reciprocal ones and your exponentials. Inequality regions, unlikely, you know, where you shade a region. Indices, not going to come up on its own, but might come up when you need to get into a form to differentiate or integrate, or maybe like get your form in a certain answer. Inequalities, possibly reciprocal one, quadratic or even linear. Linear is a bit easy, so I doubt you get something like that. You might get a linear and a quadratic together, or a reciprocal normally comes up with a solving graphically style question, but because you already had that, bit less likely to come up. But remember, when you solve reciprocal inequalities, if you move something across or times across the denominator or divide by it, but you wouldn't really want to do that in this case, it changes the sign, so just watch out for that. Integration, basic tendency one, that came up in 2022 as well, but I don't think it's going to come up again because it was quite integration heavy paper one, but again it could, so you'll see that if you do the 2022 paper. Reverse chain rule surprisingly didn't come up yet, and I think it will probably come up with differential equations if it does, because that's what normally happens, right? You get an integral, it's the integral of a fraction, you use partial fractions to split it, and then each one becomes a reverse chain rule. And they're always worth a lot of marks for differential equation ones, so really, really practice those and like time yourself maybe, because it is the place where people normally like lose marks, is that question. What else? Finding areas came up already, very unlikely. No, it's not going to come up. Differential equations, talked about that. Parametric integration, mentioned that already, but I think differentiation more likely. Logs don't always come up. I put certain, so I don't know why. I just have a feeling it's going to come up this year. And if it doesn't, then the linear transformation ones are going to come up, where you log both sides and turn it into a straight line. Numerical methods already came up, but Newton-Raphson didn't, and unusually in 2022, Newton-Raphson came up in paper 2, so likely. Partial fractions, talked about that, where it comes up. Parametrics, talked about that. Didn't mention Cartesian or simultaneous equations, but sometimes like you want to find where they intersect, and that's just plugging one into the other, getting it in terms of t and solving for that. You don't need to find the Cartesian unless they force you to find it. Like, there's no advantage to finding the Cartesian and then solving simultaneously. Just stick with the parametrics and you can do those simultaneously. Just get the equation in terms of t, solve it, put the t values back. Cartesian, the easiest thing with trig, because those are the tricky ones if you need to find it, is normally get a trig function on its own, so like sine, cos or tan, build a triangle using SOHCAHTOA, because remember sine is O over h, cos is A over h, etc. And then you can use the other equation to find that trig identity from your triangle and then plug it in. That's the nicest way to deal with those. Contradiction, I put very likely, quite likely. Sometimes you get contradiction and another proof, sometimes you just get contradiction on its own, so it's hard to say. Quadratic modelling, very unlikely because it came up with straight line graphs, radians, yeah, you can read through this. Geometric, no, because arithmetic came up. These two could come up together, recursive and sigma notation. Straight line graphs, probably not, because it would have come up with circles. Maybe tangents and normals to parametrics, that's possible. Surds, only if you're getting it in a certain form at the end of a question. That's come up already. Transformations. Trapezium rule, yeah, watch out for that. It seems to be getting a little bit harder the last few years. So normally it's just a standard like use of trapezium rule, but I've got some questions on my sheet here. Watch out for when it gets combined with a like 5 plus, so a number plus or minus. You've got to do that integration separately, or a transformation. It could be. Other things I've seen are indices with them as well, or logs. Anything that you have to do some algebra to the integral to then see like, oh, I've used trapezium rule for that bit, but I have to do something else with this bit. That type of thing. Trig identities year 2 could come up again. So you saw the compound angle, but it could be with the quadratic identities, or it could be with reciprocal identities. That's a possibility. Trig doesn't always come up twice, but has been known to. And the last comment really is, or actually I missed one thing, sorry. Trig graphs and modelling, that is very likely to come up, and more like the ones where you put it into harmonic form first, then you say like maximum values and where the maximum occurs, stuff like that. But remember, maximum with trig, we don't differentiate, we always put into harmonic form to get one trig identity, and then it's like, we know what values are important, but the values that it all hinges on is 1, -1, 0. So if you plug those in and check your values, you can easily see what's the max, what's the min. Vectors, yeah, I mentioned that a bit of that already, but possibly, I think last time was like, off the top of my head, 2021, I think, or 2020. I know there's a horrible 2020 AS that a lot of people struggled with. There's a little section in here, and it's on kinematics. So it's not kinematics, but well, part of kinematics, but basic kinematics. So not kinematics as in terms of mechanics kinematics, but the pure side of it. And it talks about speed, bearing, displacement, velocity, total distance. Just watch out for those, because sometimes they sneak that in. And that is everything. I've also made like a little chart that tells you what marks you can drop and safely get an A star. So some of my lessons like came out and they're like, oh, I only missed a few marks. And then I had some lessons that were even stronger that said, oh, like I messed up the quartic question. Doesn't matter, because you can lose a lot of marks and still get an A star. And teachers won't always tell you that because they want you to work harder. But if you look at my interactive grade boundary table, you can see like tons of marks can be lost. Well, not tons, but over 20 marks can be lost. Even if you screw up a whole question, it's not the end of the world. Hopefully that helps. Let me know if you want me to do a common mistakes document. I can do that for you. But yeah, good luck with your exams.